So thank you to all of you that submitted your work that was due Friday. I want to make sure though we go over this. So if you can take out your work, um, and if that means you need to pull it up on Cami and pause this video or find that file, but I really want to make sure that we go over this together. Okay. So questions 1 through 5, you're going to use off of the given diagram. And I noticed a lot of you got this really first question wrong because it says how many people are in the club. So here's the deal. You cannot just look right here. You have to also realize that those are the people that are in band and choir, or obviously in this middle section, they're taking both, but you cannot leave out the 8. So if you add 24 to 16 and 8, your first answer should have been 50 people, okay? So make sure that you did not have just 42. For number 2, that means find the probability that you would pick a student that is in band. So if we go to the circle that involves band, that means you need to do 24 plus 2. So you would have taken 26 over 50, and that reduces to 13 out of 25. Should have been your final answer because that's in reduced form. Number 3, this says find the probability that we pick someone that's in band and in choir. And I need you to be careful. That symbol in number 3 is what we call an intersection. And when you think of intersection, you need to think of and. So the only people, or the number of people that are taking band and choir would be in this middle section right here. So we would have 2 out of 50, and that reduces to 1 out of 25. And that would be your final answer. For number 4, we have the probability that they're in band union, is what that symbol means, between the B and the C. So this means we want to find how many people out of the 50 we'd have to pick from that are taking either band or, so that union means or. So in this problem, what we have to do is we're looking at, they're either in band or choir. So we would have 24, and then we would add that to 2, and then we would add the 16. So that would give us 42, let me get my pen here, 42 out of 50, obviously all but this 8 down there, and then that reduces to 21 out of 25. I'll circle in my final answers. And for number 5, this is a complement. If you can remember that apostrophe after that B means not. As we go through this chapter, you'll find maybe other ways to kind of see what that means. But we're trying to find the probability that they are not in band. And so if we look at our Venn diagram, we can't use this 24 because those are obviously in band. We can't use the 2 because they're in band or choir. Well, that counts for band. So we want to take the 16 that are just in choir and the 8 that are not in either one. So 16 plus 8 is 24. And 24 out of 50 reduces to 12 out of 25. All right, moving on to number 16 through 14. This time we have a Venn diagram, and it tells us that they had surveyed 26. So if you look at the survey for number 6, it's asking us the value of K. And I kind of already answered 7 down here. You'll see that it's highlighted. But if we know that there were 26, all I did is I added up all the numbers that you see in the Venn diagram, which added to 25. And so therefore it leaves us with the answer that was missing. So the value of K you found should have been just a 1. So you can see my work there of how I was able to get that. Okay. So now I'm going to answer these questions. I'll try to write them down. This tends to go a little bit faster, so I don't really want to lose the Venn diagram. So I might come over on the right. I have my answers if that helps. So number 8, we want to find the probability that we would pick someone out of the survey that only had a dog. So if they only have dogs, you want to look at the part of the Venn diagram that is just the dog, owning nothing else. So your answer for number 8 should have been 7. Sorry, I didn't mean to write that. 7 out of, so I'm going to write this one down because we can see it. 7 out of 26. And that does not reduce. Number 9, we want to look for dogs and cats. So dogs and cats. Now that and, y'all, remains the intersection. So if I look right here, what we want to do this time is look for this intersection of just dogs and cats. So that would be 4 out of 26. And 4 out of 26 reduces to 2/13. For number 10, the probability of surveying that had none of the animals, so no dog, no cat, no fish. Well, in this case, we want to look for what's on the outside of those 3 circles of the Venn diagram. So our answer here would be 5 out of 26. Okay. For number 11, I'm going to scroll this up so I can read the question, then I'll come back down if I have to. For number 11, at least one pet. So the probability that someone has at least one of these pets. So we are looking for everything. So we're looking for 7 plus 3 plus 4 plus 5 plus 1 plus that one that we found at the very beginning. So if I kind of mark that we already know that K is 1, I'll put a 1 there. So really, the probability that they have at least one of those would be everything but the 5 on the outside. So your answer for number 11 is 21 over 26. Okay. For number 12, the probability that you pick one that has all of the pets. Well, if we look at our Venn diagram, that would be the intersection circles. So if we look at that intersection of all 3 circles, that is right here, and so we have 0. The probability that somebody owns all 3 pets, a dog, a cat, and a fish, is 0 out of 26, which is 0. And then I think number 13, the probability that fish and dogs, but not cats. So they own fish and dogs. Please be careful that you understand that that means that they have to have both. So the probability that they have fish and dogs, if we look at our Venn diagram, that would be right here. So your answer I have over here would be 3 out of 26. And then our last question, if I can go back and read it, is the probability of fish or dog. So number 14, it's important that you kind of understand that we are now looking at an or. So we want to know the probability that they have a fish or a dog. So we literally want to include everything in the dog circle, everything in the fish circle, but obviously we can't count the overlap twice. So we would add 7, 3, 4, 0, I'm not going to push plus 0, 1, and then obviously K we found earlier was 1. So that's 10, that's 14, that's 16. So that would be 16 out of 26. And then that reduces to 8/13. All right, for the second side of the assignment, numbers 15 through 17, we're looking at just another double Venn diagram where it is asking kids if they own a bicycle, a skateboard, or both. So the first question, find the probability of owning a bicycle and, remember that's an intersection, so A intersects B. So we are only including Joe, Mike, Linda, and Rose. And if you count the number of people that you see in this entire Venn diagram, that means all of this, there were 15 people. So Joe, Mike, Linda, and Rose, that accounts for 4 out of 15. That does not reduce. Now, when you were supposed to describe what this probability represents, you should have written down that you are including the students that own a bicycle and a skateboard, okay? For number 16, this is the probability that you pick someone that owns a bicycle, or this is a union, so that little symbol between A and B, remember, means union, a bicycle or a skateboard. So out of our 15, the only 15 people I don't want to include are Amy, Gabe, and Abby. So that would mean that there are 12 out of 15 kids, and this reduces to 4/15. And once again, you would have written down that this is any student that owns a bicycle or a skateboard. And then for number 17, this means find the probability that they do not. So that little apostrophe after the union of A and B. So if our answer to number 16 was we had 12 in that diagram out of 15 that own either or, then in number 17, we just actually want to include the 3 that do not have a bicycle or skateboard. So our answer would have been 3 out of 15, which reduces to 1 out of 5. So our last group of questions is revolving around where you really needed to make your own Venn diagram. So I want to make sure that when you're asked to make a Venn diagram, if you know that there are 30 students that were part of the guidance counselor's plans, 16 students, a lot of people want to initially come up here and just put 16. And I need you to understand that that's not correct, because 16 has to be the total in the entire Spanish circle. So if you can see right here where I'm circling, 11 plus 5 is 16. So when it says 11 students want to take Latin, we can't just slap an 11 right here. In this circle, we have to say 5 plus what? And so that's why I'm hoping that you put a 6 there. And then if we add up right now 11, 5, and 6, which would give us 22 students, then if we do 30 minus 22, that gives us 8. And so that's why you should have an 8 there. So once your diagram's set up, let's go ahead and answer the questions. Number 19, the probability that they take Spanish and Latin, well, that would be our intersection. So that would be 5 out of 30, which reduces to 1/6. Number 20, the probability that they take Latin. Well, I'm going to use my mouse here. If they take Latin, there's 6 that only take Latin by itself, but there's 5 that take both. So we would add 5 and 6, and that would be 11 out of 30, and that does not reduce. Number 21, the probability that they take at least one. So if they're taking at least one, that means the 11 that are taking Spanish only, the 5 that are both, and then the 6 that are taking Latin only. So when you add that up, that's the 22 out of 30, which reduces to 11/15. For number 22, the probability that a student studies exactly one subject. Well, that means you cannot include, I'm going to use a different color here. That means we cannot include this middle section. No. So it would just be the Spanish and it would just be the Latin. So our answer would be 17 out of, whoa, what's going on there? 17 out of 30. Okay? And then for number 23, we have one of those complements again, which means the probability that a student takes neither subject. So that's a not. Well, if they're not taking either subject, that's going to be, I'm going to use red here, that's going to be our outside, this number 8. So the answer to the very last question should have been 8 out of 30, which reduces to 4/15. Okay? All right, I hope that helps. We're going to be moving on now to a different part of probability. Okay? All right, good job. Make sure you have your answers fixed and they are correct.